Infinite sequences. Geometric sequences. What are they? Geometric sequences are sequences where the ratio of every consecutive number is constant. Why? Helps physicists determine the half-life of decaying materials. Interesting fact, polar bears have 42 teeth. Now, let's take a look at some definitions. The first definition that we're going to look at is a definition of geometric sequence, which is a sequence a sub 1, a sub 2, dot 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 dot, a sub n, dot 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 dot, is a geometric sequence if a sub 1 does not equal 0, and if there is a real number r does not equal 0, such that for every positive integer k, a sub k plus 1 is equal to a sub k times r. The number r is equal to a sub k plus 1 divided by a sub k is called the common ratio of the sequence. So that means any term is equal to the previous term times the ratio, and the ratio is equal to any term divided by the previous term, which leads us to the formula for the nth term of a geometric sequence, which is a sub n is equal to a sub 1 times r raised to the power of n minus 1. Now, let's take a look at some theorems. The first theorem that we're going to take a look at is the formula for S sub n, which is the nth partial sum S sub n of a geometric sequence with the first term a sub 1 and common ratio r does not equal 1 is S sub n is equal to a sub 1 times 1 minus r raised to the power of n divided by the quantity of 1 minus r. The next theorem that we're going to be talking about is the theorem on the sum of infinite geometric series, which is if the absolute value of r is less than 1, then infinite series a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus dot 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 plus a sub 1 times r to the power of n minus 1 plus dot 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 has a sum s is equal to a sub 1 divided by the quantity of 1 minus r. Now, let's take a look at the examples that we're going to be discussing in today's video. Let's take a closer look at example 1. Now, let's read the steps. Step 1, find the first term. Step 2, find the ratio. Step 3, find other terms. Now, let's read the question. A geometric sequence has the first term 3 and a common ratio of negative 1/4. Find the first 3 terms and the 10th term. We already have the nth term formula on the screen, which is a sub n, which is equal to a sub 1 times r raised to the power of n minus 1. Now, let's substitute what we know into that formula. We know that a sub 1 is equal to 3, and we know that the r, or the common ratio, is negative 1/4. And now we have a sub n is equal to 3 times negative 1/4 raised to the power of n minus 1. Now, let's find a sub 1, or the first term, and now we have a sub 1, which is equal to 3 times negative 1/4 raised to the power of 1 minus 1. And 1 minus 1 is 0, and anything raised to the power of 0 is 1, and 3 times 1 is 3. So a sub 1 is 3. Now, let's move on to a sub 2, or the second term. And now we have a sub 2 is equal to 3 times negative 1/4 raised to the power of 2 minus 1, and 2 minus 1 is 1, and negative 1/4 raised to the power of 1 is negative 1/4, and 3 times negative 1/4 is negative 3/4. So a sub 2 is equal to negative 3/4. Now, let's move on to a sub 3, or the third term. And now we have a sub 3 is equal to 3 times negative 1/4 raised to the power of 3 minus 1. And 3 minus 1 is 2. And negative 1/4 raised to the power of 2 is 1 over 16. And 3 times 1 over 16 is 3 over 16. So a sub 3 is equal to 3 over 16. Now, let's move on to a sub 10, or the 10th term. And now we have a sub 10 is equal to 3 times negative 1/4 raised to the power of 10 minus 1, and 10 minus 1 is 9, and negative 1/4 raised to the power of 9 is equal to negative 1 over 262,144, and 3 times negative 1 over 262,144 is negative 3 over 262,144, and that is a sub 10. Now we have found all 4 terms for example 1. Let's take a look at example 2. Let's read the steps since they're a bit different. Step 1, find the first term. Step 2, find the ratio. Now let's read the question. The third term is negative 6, and the sixth term is 48. Find the 8th term. Well, we have two terms, which means we have two equations. Let's set up a system of equations so we can solve for our first term and the ratio. Let's substitute what we know into these equations. Let's start with the third term, or a sub 3. We also know a sub 3 is negative 6, and for our first equation we have negative 6 is equal to a sub 1 times r raised to the power of 3 minus 1. Now let's move on to the sixth term, or a sub 6. We also know a sub 6 is 48, and for our second equation we have 48 is equal to a sub 1 times r raised to the power of 6 minus 1. And those are the two equations that we are going to use to find the first term and the ratio. Let's simplify these exponents. R raised to the power of 3 minus 1 becomes r squared, and r raised to the power of 6 minus 1 becomes r to the power of 5. Let's take a closer look at these equations. What do they share? They share a sub 1. So let's solve for a sub 1 for both equations. The first equation becomes negative 6 divided by r squared is equal to a sub 1. The second equation becomes 48 divided by r to the fifth power is equal to a sub 1. Now let's set these two equations equal to each other. So a sub 1 is equal to either negative 6 divided by r squared or 48 divided by r to the fifth power. Now we substitute one of these into our system of equations. Which one do you think is better? Well, let's do both so you can have a look and decide. We have substituted 48 divided by r raised to the fifth power in our first equation, and we have substituted negative 6 divided by r squared in the second equation. Now, let's take a quick look at the first equation on the left. Now, let's take a quick look at the second equation on the right. Which one do you think is better? Which one do you think we should continue? We will get the same answer for both, but if we continue with the equation on the left, we might have negative exponents, and if we continue with the equation on the right, we will have positive exponents. Now, let's rearrange these terms so that the variables are underneath each other so we can simplify the exponents. And 5 minus 2 is 3, and now we have r raised to the power of 3. Now, let's divide each side by negative 6, and the result is negative 8 is equal to r cubed. So that means r is equal to negative 2. Let's take a closer look on why that is the case. We can rewrite negative 8 as negative 2 times negative 2 times negative 2. And we can rewrite that as negative 2 to the power of 3, which is equal to r to the power of 3. So that means r is equal to negative 2. Now that we have found our r, or our ratio, let's move our work over so we have room to find a sub 1, or our first term. Now we can substitute negative 2 into either the first equation or the second equation. Let's go ahead and use the first equation since we have smaller numbers. Now let's substitute negative 2 in for r, and now we have negative 6 is equal to a sub 1 times negative 2 raised to the power of 2. And negative 2 squared is 4. And now we have negative 6 is equal to a sub 1 times 4. Let's divide each side by 4. And now we have negative 6 over 4 is equal to a sub 1. Let's simplify. So a sub 1, or the first term, is equal to negative 3 halves. Now we have a sub 1 and r. Let's substitute those two numbers into the nth term formula. And now we have a sub n is equal to negative 3 halves times negative 2 raised to the power of n minus 1. Since we want the eighth term, let's go ahead and substitute 8 for all those n's. And now we have a sub 8 is equal to negative 3 halves times negative 2 raised to the power of 8 minus 1. And 8 minus 1 is 7. And the result of negative 3 halves times negative 2 raised to the power of 7 is 192. So a sub 8, or the eighth term, is equal to 192. We found our answer for example 2. Now, let's move on to example 3. Let's read the steps since we have changed them again. Step 1, find the first term. Step 2, find the ratio. Step 3, find the sum. Now, let's read the question. If the sequence 2, 0.4, 0.08, 0.016, is a geometric sequence, find the sum of the first 6 terms and find the sum of the series. Now, let's write down the two formulas that we need, the ratio formula and S sub n formula. Now, let's find the ratio by checking any term and dividing it by the previous term. Let's start with 0.016 and dividing that by the previous term, which is 0.08. Let's continue down the line, and now we have 0.08 divided by 0.4, Let's continue again, and now we have 0.4 divided by 2. Now if all these are equal, that means we have a geometric sequence. In this case they are, and they all equal 0.2. Now we have our ratio, 0.2, and we want the sum of the first 6 terms. So let's go ahead and substitute 0.2 and 6 into the formula. And now we have s of 6 is equal to 2 times 1 minus 0.2 raised to the power of 6 divided by the quantity of 1 minus 0.2, and that is equal to 2.49984. Now let's answer the last question. Find the sum of the series. Let's write down the formula that we need. S is equal to a sub 1 divided by the quantity of 1 minus r. We know a sub 1 is 2. We know r is 0.2. So let's go ahead and substitute that into the formula. And now we have s is equal to 2 divided by the quantity of 1 minus 0.2. And our result is 2.50. We found our answers for example 3. Now it is your turn. So go ahead and pause the video here so you can take your time to answer this question. And I'll show you the results in 3, 2, and 1. Did you get it correct? Awesome. If not, there's always tomorrow.